Chapter 5. Chemical Reactions. Chemical Equations. A chemical equation is a short way to show a chemical reaction using chemical formulas and symbols. It is much easier to show a chemical reaction using symbols than it is to write out a sentence showing the chemical reaction. All chemical equations have two parts, reactants and products. The reactants are always on the left, and that's what you're mixing together. We say that's what yields the products. That's what you have at the end. Here are a few examples. The first, H2 plus O2 yields H2O. H2 and O2 are our reactants. That's what we're mixing. That's yielding H2O, water. That's our product. The second example, sodium hydroxide and hydrochloric acid are reactants. That's what's being mixed. They're yielding the products, sodium chloride and water. The last example has three reactants and only one product. Sulfur dioxide, oxygen, and water are producing sulfuric acid. Let's try another example. Here we have sodium mixed with oxygen to form sodium oxide. The reactants are the two chemicals being mixed, sodium and oxygen. There's one product in this case, sodium oxide. You may notice there are two oxygens in the reactants, but only one in the product. There's also only one sodium in the reactants, but two in the product. That is because the equation is not balanced yet, but we will deal with that later. Here are three examples for you to try. Identify the reactants and products. Pause the video, do the examples, then check your answer. Here are the answers. Now let's add another step. After figuring out the reactants and products, let's count the number of atoms in each. Here we have the reaction between potassium iodide and chlorine to form potassium chloride and iodine. The reactants are on the left, potassium iodide and chlorine. The products are on the right, potassium chloride and iodine. The next step is to list the elements, potassium, iodine, and chlorine. We list them for the reactants and the products. Then we determine the number of atoms in each of the reactants and the products. We can see in the reactants that there is one potassium, one iodine, and two chlorines. In the products, there's one potassium, two iodines, and one chlorine. Here are two examples for you to try. Pause the video and give them a try. The answers will be shown followed by a detailed explanation. Here is the detailed explanation. First, list the elements: potassium, carbon, oxygen, barium, and chlorine. That we can see within subscript 2, there are two potassiums, one carbon, three oxygens, one barium, and two chlorines. Next, we list the products. I like to list them right across from each other: potassium, carbon, oxygen, barium, chlorine. There's one potassium, one carbon, three oxygens, one barium, one chlorine. Now example number 2. List the elements: magnesium, nitrogen, oxygen, hydrogen, and carbon. Let's list the products directly across from each one: magnesium, nitrogen, oxygen, hydrogen, and carbon. Remember, no subscript means it's a 1, so there's one magnesium. The 2 outside parentheses means 2 nitrogens. There are 3 oxygens times 2 is 6. There are 8 hydrogens because there's NH4 times 2. 4 times 2 is 8. Then we come across 2 more nitrogens. So we write 2 plus 2. We want to keep them separate. They're separated by a plus sign. Same thing with the extra oxygens. We want to write it as 6 plus 3. In the products we have 1 magnesium, 2 nitrogens, 3 oxygens, plus 3 in the next compound, 4 hydrogens, and 1 carbon.